Okay, so I think I'm live, right? Radhe Radhe everyone. Uh, the connection is a little bit not that good. Yeah, no, it is okay. Okay, it is green, right? Well, actually, it takes a little bit of time to get to that settings, I guess. Uh, this is running on pretest. Yeah, okay, time limit exceeded. So I will be explaining A, B, and C today. Okay, someone, whoever is watching this right now, just confirm me if I'm audible or not. Okay, just quickly confirm. Vishesh offer. Otherwise, what I'll have to do is I have to check it by myself, and it's gonna take up a lot of time. Okay. Let me also check the escalator. Is there any lag? Yeah, it is. So the lag is okay. And am I audible? Okay, I'm properly audible, right? So let's start with the video. I mean the solutions. Yeah. See, the first problem is one day after waking up, your friend. So let me do one thing. I'll just put this escalator out of the box, okay? So that state is in different thing, this is in different place, and the code is in different place, right? Well, no, I think it was way better earlier. Okay, so let's go with the first problem. Brogramming contest. One day after waking up, your friend challenged you to a programming contest. In a programming contest, you're given a binary string S of length n and an initially empty string t, and it is also binary. Okay, during a programming contest, you can make either of the following moves any number of times. Remove some suffix from s and place it at the end of t, or remove some suffix from t and place it at the end of s. To win the programming contest, you must make the minimum number of moves required to make s contain only 0 and t contain only 1. Okay, so what does it mean? So basically you are having two strings, one is s and the other is t. Okay, so there are two strings and s is not empty, and it is a binary string, let's say 1001110, somewhat like this. Okay, and t is initially empty. Okay, it is null. And now what it was given, that we have to make a, sorry, s contain only 0 and t contain only 1, right? That is the condition that we were given to make. Now see, what we can do is you can remove a specific part of it and put it in t. Okay, 101110, right? And like you can also do something else also. Let's say I'm removing this 1110. Okay, I'm removing it from here and putting it over here 1110. Okay, and then again what I can do is I can remove a little bit of suffix from t and put it in this. Okay, then I can do it like any number. To do it is remove the first, remove from the end the first occurrence of 1. Okay, that is this whole thing. I think you won't be able to see. Yeah, this whole thing. Okay, this whole thing you can remove it, and it was 101110, right? So now it comes over here. Now from here you do the opposite thing. From t you do the opposite thing, that is you remove from the last 0, I mean the first 0. Okay, so 01110. Okay, which makes it 01110. Now again do the same thing. So 1 1 1 0, 1 1 1 0, and again do the same thing. 0 gets removed from here and it goes over here. So this is the most best, I mean this is the best approach if you want to make all the elements of S as 0 and all the elements of T as 1. Okay, so this is the best approach that you can do. Now how to calculate the number of moves that you have gone through. Okay, so let's say initially we had this array. So what we were doing is, whenever we are encountering the first one we are encountering, it means we have to make a move. Okay, after that you encounter a 0, you have to make a move. After that you again encounter a 1, you make a move. After that you again encounter a 0. So it is like alternatively, first you have to check for the 1, then 0, then 1, then 0. Okay, and how many such cases are there? There are 4 cases. Okay, there's such 4 cases. So let me take an example out of here. If you look at this example, okay, I don't know whether it is quite zoomed enough. So now I think it's visible for you. So 0 0 1 1 0. So 1 occurs over here and then the 0 occurs over here, which means there will be 2 operations, right? And for the last case, this one 1 0 1, so 1 occurs, then 0 occurs, then 1 occurs. So there are 3 such patterns. Okay, so the answer is 3. And in this fifth case, everything is 0, so 1 never occurs only, so it's 0. Okay, so it is clear, right, how we're going to do it. First of all, you're going to find the occurrence of 1. After that, you're going to find the occurrence of 0, then again 1, then again 0, then again 1, then again 0. And how many, like the number of occurrences that you find like that, you can directly say that that is the like number of operations that you have to perform. Okay, so let's move on to the code. So yeah, programming contest, a very simple code. We are having S. I don't need T. Okay, right, that is a hypothetical thing, we don't have to consider that. Let me do one thing, I'll just put this device into charge so that if there is any lagging from my end, so it won't be lagging. Okay, because my health check is showing that it's not that, there's some lagging thing. Okay, well, so taking everything into consideration, so what we initially know that the initially need is 0. Okay, so while it is 0, it's okay, we're okay with it. The first time we encounter a 1, okay, the first time it is not a 0, that is it's a 1, answer becomes plus plus, and the need gets changed, that is from 0 it becomes 1, otherwise it from 1 it becomes 0. Okay, so basically this operation is like what to say, I don't remember the term properly. It is like exchanging the from 1 to 0 and 0 to 1. I don't remember the term what it says. Okay, flipping, yeah, it is basically for flipping. Okay, and this is answer plus plus. So I guess there won't be any problem. And anyways, people who can't like write on the live chat, I think if you subscribe my channel, then you will be able to write it. Okay, okay, to be able to chat, subscribe, because I have put a subscriber only chat. Okay, so I guess one is clear with you guys, right? Is it clear? Is one clear with you guys? Oh, I forgot to start the board. Yeah. Yes, yes, yes. Great. Let me end the poll. So let's move on to the next problem. Okay. Yeah. Okay, I know it is finished. So variety is discouraged. Okay. Define the score of an arbitrary. Okay. Yeah. define the score of an arbitrary array B to be the length of B minus the number of distinct elements in B. For example, the score of 1, 2 to 4 is going to be 1. Why? Because the length of the whole array is 4 and number of distinct elements is 1, 2, 4, right? That is 3 distinct elements are there, right? The score of 1, 1, 1 is going to be 2 because the whole length is 3 and there is only one distinct element. So 3 minus 1 is 2. Okay, clear? Now, what you have to do is you can remove at most once just one contiguous subarray. Okay, you can remove at most once contiguous subarray, and after you're done with that removal, you have to maximize the score of A such that the output one that you have to maximize the value of A. Okay, I mean the score of A, and after doing that, so let's say you can you get a value and it is maximized. Okay, but you can like you can shorten the array more. Okay, so if you can shorten the array more, so in that case you know one thing, that you have to go for it because it also tells us that output the one that minimizes the final length of A. Okay, after the operation. So let me write it down. You're given an array. Okay, you're given an array, or let's say I won't define the array like this. You're given an array. Okay, and in that array what you have to do is you have to find out a specific subarray. Okay, you have to find out a specific subarray and you have to remove the subarray such that the score is maximized. Okay, and let's say if you're removing this subarray, whatever the score is, and if you're removing this subarray, whatever the score is, so you will be prefer to do the red one because you have to minimize the length of the array that is remaining also. Okay, so that is clear, I guess. Now the condition is like, how are you going to know that what is the subarray that you have to remove? Okay, because that is the important thing, right? So anyone who did this problem, anyone who have done this problem? Okay, so I can see that there is some FPS issues. Oh, how bad my chat is lagging though. Okay, so let's go with how bad my chat is lagging. Now I think it is okay. Okay, so so now we have to come up with an approach, right? So how can we come up with an approach? So first of all, we have to find out, so what is this question telling us in more lame terms? Okay, because this is a very complex term, whatever the question is telling us. So we have to simplify the whole thing. Now see, what is the score? The score is basically length of the whole array minus the number of distinct elements. But don't you think that in this case, like if you're going with that formula, so you have to consider two things. That is, one is the length of the whole array, okay, and the other thing is the number of unique elements. Okay, so what is n minus unique elements? It is equal to the number of repeated elements, right? It is equal to the number of repeated elements. Now since it is equal to the number of repeated elements, so what we have to do is we have to increase the number of repeated elements, right? That is something that you might think of, right? Now the condition is that if you want to increase the number of repeated elements, so that is like so yeah, you can't do that, right? You can't increase the number of repeated elements, right? So this is a specific thing that you have to consider, that since n minus unique, this is what I have to maximize. Okay, and I know that if I am removing one element, so from that one element what happens, this n becomes minus 1 and this unique also becomes minus 1, right? But sometimes this unique may not become minus 1 when you're removing an element which is repeated. That is, you're not removing all its occurrences. So it is not decreasing the number of unique elements. Right? You're getting it? What I'm meaning, what I'm trying to say. So our aim is either you can have -1 or 0. But our aim is to make it -1 -1. Okay? Because we also have to prioritize on the fact that we have to minimize the length. So our aim is to find out the subarray such that, let's say the length of the subarray is m. Okay? So such that what happens, this n becomes -m and this unique becomes -m, which is basically nothing but removing all the unique elements. Okay, so what we have to do is we have to remove all the elements that occur only once, right? How to do it? Now let me tell you how to do it. So let's say you're having the array, again I'm drawing it, and you know that there are few elements which are unique. How can you find it out? You can have a frequency array and check out all the elements, all the frequency of all the elements by doing one-time traversal throughout it. Okay, and once you're done with the one-time traversal, what you can do is after that you're going to again traverse throughout it. Okay, again traverse throughout, and now when you're traversing throughout it, you're going to find out the elements which is having a frequency of 1. That means it is unique, because that is what we have to remove. So what you can do is you can mark them as true or 1. Okay, and the remaining elements you can mark as false or 0. Clear? So let's say some of the elements are going to be 0, that is false, and some of the elements are going to be 1, right? What you have to do is you have to find the longest substring, I mean not substring, the longest subarray consisting of only ones. And I think you know how to do it. Okay, this thing I hope you know how to do it. Still, I'll just explain you. What we have to do is, like, let's say I'll take another example. Like, let's say this was 1. Okay, so in this case, if this was 1, so what we have to do is, this is the longest subarray of consisting only of ones, right? So the answer is going to be 3. How to do it? If the previous element and the present element is equal to 1, so count plus plus. Okay, otherwise count is equal to 0. Clear? And you were also given that you have to find the L and R, that is the the starting point and the ending point. Okay, so once you get the count, so at this position the count becomes 3, right? So let's say this position is 0 1 2 3 4, right? So we know 1 is 4, something is 4, and the previous element is going to be 4 minus 3 plus 1, that is R minus count plus 1. Okay, so what are the 2 points? Since R is the last point, so obviously you are presently at that point, so let's say I only. So I minus count plus 1 comma I. Okay, and when will this be valid? If it is the maximum. So what you can do is you can also have a element called answer, which is going to consider the maximum value of count that is possible. So only when answer is lesser than count, then only you can check this into our consideration. This is a valid limit, and make answer is equal to count. Okay, simply like whatever you do when you're going to find the maximum thing. If you want the code, I can go walk you through the code. Okay, see, if you're having any doubt, I can see there are a lot of people watching it right now. Just write it in the live chat. Okay, anyways, like, are you guys being able to write? Because the viewing is like good, but I don't see a lot of people writing. Okay, so just check if you are being able to write or not. Okay, okay, so see, what we are going to basically do is, hello. Okay, so you guys are being able to write, right? Great. So L is equal to -1, R is equal to -1. That is the starting point and the ending point. Okay. Then I'm taking the ARR and BRR well enough. I know what to do. Then I'm taking the input of ARR, and since I was just mentioning you have to find the frequency of the whole thing. Okay. So I find the frequency of the whole thing, and at any position where I find that the frequency is 1, that means it is a unique element. So it means we have to remove that. So it becomes 1, and otherwise it becomes 0. Okay. Clear? Now when answer is equal to 0, C is equal to 0. C is basically nothing but count. Okay. C is count, and answer is the maximum value of count. So initially both of them are 0. So what we are going to do is basically we go and walk throughout the whole thing. Okay. We walk throughout the whole array, and at any position if we find that ARR of I is equal to 1, so in that case we know that the count has to be incremented, right? Because this is a 1 and we have to remove it. So count plus plus. And if at any position you find that count is greater than answer, which means now answer is going to be replaced with count. So answer is equal to C, one thing. The limit that L comma R becomes I, and L becomes I minus C plus 1. I just explained you why. Okay. Otherwise LC is equal to 0. That is, if AR of I is 0, it means that there is no count. So you can directly write it as 0. Okay. Now we also have to do this checking after we have done that whole traversal. Okay. And after that what we can do is we have to do the checking that if L is equal to -1, R is equal to -1. That is, none of the conditions satisfies. Okay. So that means we don't need to do any like removal of the sub array. Okay, in that case we can directly output 0, otherwise we can output the L comma R. So why do I make it L plus 1 and R plus 1? That is because we know that normal coding is based on 0 based indexing, but in the question it was given that it is 1 based indexing. Okay, so is it clear? Is B clear? Can you explain again? Yeah, I can explain again. Sure. Can you tell me which part you want me to explain again? Just tell me which part you want me to explain again, quickly. Do you want me to explain the whole thing again? I think he is typing. The last part after we have chosen to create the array with 0 and 1. Okay, see, after you have chosen the array with 0 and 1, okay, so what is our main goal? We have to find out the largest sub array consisting only of ones, right? So see, what is the value of CNT and what is the value of answer? Just notice one thing over here. So it is 0 and 0, right? Initially. Now I'm going to traverse one by one. So it is a 0. So nothing. I have to do nothing. Count remains 0. Okay. Then I move over here. It is 1. So now what happens? Count becomes 1. And since answer is lesser than 1, so this becomes 1, and the value of L and R, so I think it won't be visible for you. The value of L and R, which were initially -1 and -1, now there is a change in it. R is going to be I, right? So let me just also give the indices 0, 1, 2, 3, 4, 5. Okay. So R becomes now 1 and L becomes I minus count plus 1, right? That is the formula. What is the formula? I minus count plus 1. Clear? So I is 1 minus count is 1, so that is 0, plus 1, that is 1. So 1 comma 1 is the first part that we have done, and we know that it is a valid thing. Okay. Then we move on to the next element, that is this 1, and now again it becomes 2 and this becomes 2. So what is the new pair now? It is going to be 2 minus 2 plus 1, that is 1. Then again we move on to 3, which is also a 1, which makes it 3, and this makes it 3. Now it becomes 1 comma 3. You can do the calculation by yourself. And now we move on to 0, right? The moment we move on to 0, count becomes 0. Okay, and there is nothing over here, nothing. We don't have to worry about it. Okay. After that we get count as 1. Why? Because we encounter another 1. Now in case if you want to check, obviously you won't be checking because we are only going to consider if answer is greater than that. But if you want to check what should be the value of L and R if this would have satisfied, that is if 1 was greater than 3. Okay, just a hypothetical situation. So in that case what would have happened is the value would have been, this is 5, right? 5 and I minus count plus 1, that is 5 minus 1 plus 1, that is 5, right? So it begins at 5, ends at 5. So this is how we are going to make the LNR. But obviously this is a hypothetical situation, so we don't have to consider that. So what is the answer for this? 1 comma 3, right? But so the answer is 1 comma 3, that is it starts at 1 and ends at 3. But since we are dealing with 1 based indexing, so it is going to be 2 comma 4. Okay. Now is it clear? Is it clear? So if the array is okay, I'll just read it from the array. Okay, so if the array is 1 2 1 3 1 4, then the array form will be 0 1 0 1 0 1 1 2 1 3 1 4 exactly, and the answer is 2 comma 2. Yeah, right. The answer is 2 comma 2. Yeah, the answer is 2 comma 2. You're right. Should I move on to C? Guys, at least vote. Okay, yeah. Yes, or did I put the vote? No, I can't vote it. Okay, so yeah, it's a yes, right? That's in the poll. Okay, so let's move on to C. Remove the ends. You have an array of length n consisting of non-zero integers. Initially you have 0 points and you will do the following until A is empty. Let m be the current size of A. Select the integer I where 1 is lesser than, like 1 is, I mean I is in the range from 1 comma n. You gain absolute value of AI coins. Okay, that is if A of I is in negative, you have to make it positive, and if it is positive, you can keep it positive. Okay, that is what absolute means. So if A of I is lesser than 0, you remove all the elements that are before it along with that element. Okay, and if A of I is greater than 0, then you remove, sorry, I meant the opposite. Okay, you delete the suffix, all the elements beginning with A of I. Otherwise you delete the prefix, that is the elements before A of I, including that. Okay, now see, there are two conditions, right? So what are the two conditions? One condition is if a of I is lesser than 0. So in that case, we are deleting the suffix. Okay. And the other case, if it is greater than 0, you are deleting the prefix, right? According to this. And what you have to do is you have to find the maximum number of coins you can have at the end of the process. So if you go and like I have drawn the whole thing. So if a of I is lesser than 0, so you remove the elements that are after it. And if it is greater than 0, you remove the elements just before it. So now think about it. What should be the best approach to do it? Okay, what should be the best approach to do it? So whenever you're finding that a of I is lesser than 0 and you're removing the elements that are after it, so isn't it better that you do all the elements that are a of I lesser than 0 after it? What do I mean by that? I'll just tell you. So let's say I'm only going to consider the situation where a of I is lesser than 0. Okay, so in that case, if at this position there is an element that is lesser than 0, so it means that I'm going to delete all these elements, right? I'm going to delete all these elements and I'm going to add this element to the score, right? I'm going to add this element to the score. But won't it be better that if let's say if this element was also negative and this was also negative, so which one should I take at the beginning? Should I take this element or this element? I should obviously take the element that is at the last, right? Because that is going to be removed. Okay, a of I less than 0, delete the suffix. Yeah, that is going to be removed, right? So I have to take this element first and this thing gets removed. Then I take this element and then this thing gets removed. So basically for the negative elements, one thing we can directly say that we can check out all the negative elements that are towards the right of that negative element. Okay, and we can find that the addition of all those elements are going to be the score. Clear? Like what do I mean by that? So let's say I'll just draw a different thing. I'll just make the stroke a little bit wider. So let's say you're having this array and there is a negative element over here. By negative I mean okay, I just go with negative. Okay, there's a negative element over here and a negative element over here. Now if you want to consider all the negative elements, so what are you going to do? First of all, you're going to remove this element, then this element, then this element. You can't do it in any other order, right? Because if you are going to remove this element after all, so first of all you have to remove this element, then this element. So there is an order. Because if you remove this element at the beginning, what happens is all these elements get vanished. So you can't remove those elements and these are going to contribute to you. So it is better for the negative elements, you start from the right and move towards the left. Okay, so this is for the negative elements, and we know that for the positive elements it was the opposite thing. So it can be generalized that for positive elements it is the opposite, that is move from the left to the right. Clear? Now see one more thing, that how are we going to tell that what is the maximum score that we can achieve from here, right? Because that is the main thing that we are mostly concerned about. Now since we have to achieve the maximum score over here, so what we can do is we can take again we are going to have the array well beforehand, and let's say I'm drawing a partition over here. Okay, so for this part I can find out in this direction, and for this part I can find out in this direction. Okay, clear? Why do I do that? Because the deletion occurs like this. First this element gets deleted, then this element, then this element, then this element. And in the opposite criteria, the deletion occurs like this. This elements get deleted, then this, then this. Okay, clear? So that is the reason we can do it like this. So what does this mean? It means that if you are holding a position at the partition, okay, if you are at a partition, specific position, so you have to find out the number of negative elements towards the right, right and the number of, I mean the sum of negative elements towards the right and the sum of positive elements towards the left. Okay, sum of negative elements and this is sum of positive elements. So what you can do is you can add this with this. And remember one thing, whenever you're going to check for sum of negative elements, you have to make it absolute, because sum of negative elements is a negative element. But what you can do is you can have the whole thing as you can make it positive, right? Because we were given like the freedom to make it absolute, right? We were given the freedom to make it absolute. So is this logic clear? Some positive, some negative. And for every specific partition, what we can do is, for every specific partition that you come across, you can find out the sum of the left positive elements and sum of the right negative elements, add it up, and whichever is going to give you the maximum for every partition, like check for all the partitions, check the value of this sum and find out whichever is the maximum. That is going to be the answer. Okay, is it clear? I think I can walk you through the code, but I have done something different which I don't want you to walk you through. What I have done is I also explain, but is it clear? Is everything clear till now? Then only I'll explain the code. See, if there is no response, I'll just assume that it is clear. Okay. ओल्ड कोर्सर आईडी में काफी सारे स्क्रिप्ट सॉल्यूशन किए, काफी सारे नहीं होगा शायद. I think there is only one. No, in the old Codeforces ID. Yes, but with the array, the script solutions are because of like the plagiarism thing. No, it's because of the plag thing. I get it. This one, no. This was because of the plagiarism thing, because during that time I used to share the whole code along with the explanation, right? Now I just make videos after the contest. So after like those plagiarism checks, after that I just decided not to post during the contest. But with the array, like, you know what, I whenever I'm posting something, I tell people that don't just blindly copy it, don't just blindly like follow it what I'm posting. Since that is the reason sometimes I do what, I just don't walk you through the code. Okay, I just tell you to do it by yourself, because I feel that contests are not just for ratings. Thanks, man, thanks. Because I feel that contests are not just for ratings, it is just for learning also. And I have seen one thing, that people learn more during, many YouTubers are doing live stream kar raha hai, and they give live solutions too. Exactly. But I never did that live thing, but I used to post solutions, yeah. And this is like, at this moment, I think it is past. Anyways, it is past, and it is not right. Okay, it is not right to do. Yes, but with array 1, 2, 3, minus 1, minus 2, minus 3, then the answer will be 0, right? No. You didn't get it. Okay. See, this minus 1, minus 2, minus 3, this we are going to consider. I'm not saying you, but this will increase the acceptance. Yeah, I get it. Just a minute. Huh? So see, what this happens is that in this condition, this minus 2, minus 1, minus 3 is going to have the absolute values, right? What I just mentioned, that whenever you're having the absolute values, the negative becomes positive. So minus 1, minus 2, minus 3, it becomes 1, 2, 3. The sum is minus 1, minus 2, minus 3. But whenever you're adding it to the answer, it is going to be 1, 2, 3. So it is basically going to be nothing but 3, 4, 5, 6 into 2. That is 12. Okay. if you want to see how, like, I'll just walk you through this example. Consider the reverse. Okay, no, why in the reverse, why would it be why would it be like 0? In the reverse also it won't be 0, right? I'll tell you why. Okay, 1 2 3 1 1 2 3, right? So see, this is a very interesting thing, like, which you may not come across initially. Silly mistakes occur like this. See, -1, -2, -3, right? These are the first three. Okay, let me just use a little bit of like this: -1, -2, -3, 1, 2, 3. Right? This is what you mean. Now see one thing. What I just told you, you have to find out all the negative numbers towards the right and all the positive numbers towards the left for every specific partition. So if you're drawing a partition over here, okay, so what are the negative numbers towards the right? -1, -2, -3. That is 6, right? And what are the positive numbers towards the left? Nothing. So the answer is going to be 6. Okay. And if you're putting a partition over here also, then also the same thing occurs, because 3, 2 and 1 are the positive numbers towards the left. So the answer is also 6. So basically the answer is going to be 6. Do you get it? Why? Yeah. Great. See, if you want to go through the code, I can walk you through the code. But what I have done is, instead of doing the normal approach, because at that moment I couldn't come up with this, what I've done is, whenever I found a negative chain, a chain of negative numbers, I have added it up. Okay, which also gives us the same solution only. So whenever I find a chain, I have added it up, and whenever I find a chain of positive numbers, I have added it up, which becomes -6, 6. Okay, so basically, like, if you do the operation on this also, it is going to be the same thing. Okay, if you put a partition over here, it becomes 0. If you put a partition over here, it becomes 6. And if you put a partition over here, it becomes 6. So basically, in this case, what I am doing is, I am eliminating these partitions. Okay, these partitions, because I know that these are invalid. The partition in between, like these partitions, because I know that they are invalid. I don't need to do it. So I'm just putting a chain. Okay, but you don't need to do this, because this is going to be more complex for you. So you can just do the normal thing. Okay, just go for the normal approach. But if you want to see the code, like, this is normally the code what I have done. Don't focus on till this part. Okay, don't focus till this part. So after that, I have made a prefix array for positive numbers and a suffix array for negative numbers, and then I have put the sum of the positive numbers, okay, in that prefix array, and some of the negative numbers in that suffix array. And then for every partition, what I do is, I check if the prefix thing is, so this is not, even this is not needed. Okay, even this is not needed. You can directly go for this. Answer is equal to maximum of answer comma position of I plus absolute of negative plus I mean, not position, it's positive. Okay, so the positive numbers before that point and the negative numbers after that point. And just as you mentioned, like the thing that you were mentioning, that it should be 0, right? So we also have to put a partition at the beginning and a partition at the end. Okay, so I hope this is clear. So this is the last question. Okay, this was the last question. I hope this is clear. After this, I'll just rate up the problems. Easy, medium. See, the first problem, I don't remember again. The first problem, Brogramming Contest. It was not that easy, like not the lead code easy problem. So yeah, somewhere between easy and medium. The second question was like you have to find out what the whole question is about. So just because of the logic, I'm giving it a medium rating. And the C was like remove the odd. And over here also, just because of the logic, I'm giving it a medium rating. Okay. So this is somewhere between easy and medium, and B and C are both a medium, and both of them are like easy to like implement, but I'm giving it a medium rating just because of the logic that you have to come up with. And D, I got a TLE on that, so I won't be discussing it. Okay. And E, I haven't coded. F, I haven't coded. The questions like if there was no time complexity to be considered, so like the questions were easy enough, apart from the fact that we have to go with the time complexity thing. Okay. So yeah, that's it from my side. Any doubt you guys have? Otherwise, I'll just end the live stream. Well, it seems that you guys have no doubt. So yeah, that's it from my side. Thank you. Radhe Radhe.